Hello students, my name is G. Nikita and Pharmacy Assistant Professor, Department of Pharmaceutical Chemistry. So I will deal the pharmaceutical inorganic chemistry for Form D first years. So today we are going to discuss about the topic name is errors. So it is the first topic which is involved in the pharmaceutical inorganic chemistry. So the topic name is errors. So in this we will discuss about introduction, errors, accuracy, precision, sources of errors, types of errors, how to the methods of the minimizing errors, test for rejection of the data, significant level, rounding of figures and references, books what we have to follow for this topic. So what we will learn here in this topic means we will discuss about the introduction and what is the definition of the errors, and also we will discuss the errors with the some of the examples and what are the sources of the errors means how the in what way the errors will be occurred and what are the types of the errors, and also the methods of minimizing errors means by using what methods we can able to reduce the errors, and also the introduction and the definition of the accuracy means what is the accuracy, and also with the examples, and what is the precision, and what is the test for rejection of the data, and what is a significant level, and what is the rounding of figure. So in this topic we are going to discuss the definition of the errors, sources of errors, and also the what are the types of the errors and how we can able to reduce the errors, and also the introduction and the definition means the meaning of the accuracy means what is the meaning of the accuracy, precision, and also the what is the test for the rejection of the data, and what is the significant level, and what is the rounding of figures. So let's see introduction. So what is it means? It is been said that the reliability, reproducibility, and accuracy are the basic for the analytical chemistry. So, what are the important for the analytical chemistry? Means reliability, reproducibility, and accuracy. The task for the analytical chemistry will be to devise meeting which results that are reliable, reproducible, and accurate. So, but every measurement made, no matter how systematically and carefully, is subject to some degree of uncertainty or the error. So, unfortunately, the magnitude of the uncertainty or the error is a difficult quantity to be determined. So it is not due to any handicap on the part of analytical chemist. It is due to the fact that magnitude of the error in a measurement which is equal to the measured value minus the true value. So it is not a real determinable. So since the true value of the measured property may be known to all. So here nothing but, so if we did any of the experiment, we will get the result. So the result should be accuracy means it should be good result. So it should have the good result, and also if we perform the three or more trials, no, at that time it should produce same result. So that is the reproducibility. So reproducibility means if we perform more three or more than 3-4 times trials, so at that time we should get the same result. So if the analyst has been performed the experiment, no, it may be occurs not due to the all the times it may not occurs due to the mistake of the analyst, the person, those who are performing the experiment, and also it may occur the error many other reasons. And also the true value of the property is really an exclusive physiological quantity. Sometimes man perhaps is not designed to know all that one can aspire and decrease the margin of uncertainty so the results become sufficient, accurate to an acceptable level. Error, accuracy are the relative terms that can have in the different meanings. So for example, if we take any of the analyst, he has been performing the experiment. So may tolerate the high margin of the error and accept the particular result as accurate. So if the person has been doing the experiment as the analyst, so if the result has been whatever the result we should get, no, just if he get the result just near to that value, no, the value can be accepted in case of the doing experiment. But in case of for the research work, it is not acceptable exact the result we should get. Means here if in case of considering of the experiment, means if the value that we won't get the same value, but also we can get the value just near to it. And but in case of the research work, that we should get the same result. And if we get any of the deviation, means just like in case of the zero point 0.5 differences also in the research work, this result has not been accepted. So let's see what is the error, accuracy and precision. So error means the difference between the experimental mean and the true value. So what is the true value means? If before performing any of the experiment, there will be the true value. So this much amount of the true value that we should get if we do any of the experiment. So how we get the error means if we perform the experiment, we will get the result. So if the result is different means that is the experimental mean, and the true value is termed as the absolute error. So absolute error it may becomes in a positive or the negative number. So often the relative error is used. So the relative error refers to the value found by dividing the absolute error by the true value. So what how we can able to find the error value means the measured mean value. So if we do the experiment, so after the completion of the experiment, we will get the some amount of the value. So that amount of the value minus how much amount of the value we should get, that is the true value. So measured mean value means experimental value after completion of the process, and the true value means how much amount of the value we should get, that is the error. So relative error means measure mean value minus true value by true value. So the relative error is expressed in as percentage by multiplying the relative error by 100. If we want to represent the relative error in the percentage form means we should multiply by 100. If we want to express in the terms of parts per thousand means we have to multiply by using the thousand. See, I will explain it again. The error is nothing but the measured mean value means after doing of the experiment, how much amount of the value we got minus that how much amount of the value we should get. That is the true value. So it is the error. The relative error means the measured mean value minus true value by the true value. So if the relative error we should get in the form of the percentage means we have to multiply the whatever the value we got into 100. So if we want to express in the term of the parts per thousand means we have to multiply the number with the thousand. So example if we took means if we can take the example like if a person means a chemist has been performing the experiment means has prepared the buffer solution for the pH 4.62. So if it has been repeated the experiments for 3 times. So he got the different values like 4.59, 4.63 and 4.60. So among these three values, we have to find what is the absolute error and what is the relative error for the each value. See here, what is the question? The chemist prepared the buffer solution for the pH 4.62. So he has been done the experiment for the more than for the 3 times. So if he had repeated the experiment for the 3 times, no, at that time he got the values, different values. That is 4.59, 4.63 and 4.60. So among these three values, we have to find out what is the absolute error and what is the relative error. So what is the formula we have to apply here for here means the experimental value. So what is the experimental result we get minus true value? So what are the experimental values here? We got that 4.59, 4.63 and 4.60. What is the true value we should get? That 4.62. So this is the true value and these are the experimental value. So what is the formula we have to apply here? That is measured mean value minus true value. So this is the measured mean value minus true value. See here 4.59 is the measured mean value minus 4.62. So what is the value we got? Minus 0.03. And here 4.63 minus 4.62. So what is the value we got? 0.01. Next 4.60 minus 4.62. So how much we got? Minus 0.02. So this is about the absolute error. If you see the relative error, so we have to divide the relative absolute error by true value. So then we will get the relative error. So here absolute, what are the absolute error we got? These are the three absolute values and these three absolute values should be divided with true value, that is 4.62. See here minus 0.03 by 4.62. So how much we got? 0.0065. And here for the second value 0.01 by 4.62. How much we got? 0.002. And here minus 0.02 by 4.62. We got 0.0043. So if we calculate, if we want the relative error in the form of percentage, means we have to multiply with the 100. The relative error in with 100. So if we calculated the first result, that is 0 minus 0.0065 into 100, means we will get minus 0.65. And also here 0.002 into 100 means 0.20. And here minus 0.0043 into 100 means here 0.43. If we want to express this in the form of parts, if we want to express in the parts per thousand, means we have to multiply the relative error value into 1000, then we will get the result. So by this we can able to calculate the absolute error and the relative error. I will explain it again. See here, this is the measured mean values and this is the absolute error. So this is a true value, this is the measured mean values. So we have to differentiate, we have to do the minus the differentiate value minus true value, then we will get the absolute error. So this absolute error, if we divide it with the true value, means we will get the relative error. So if we want the relative error in the percentage, means we have to multiply by the 100. And if we want in the form of the parts per thousand, means we have to multiply with the 1000. So this is about the error. Next, accuracy. So the meaning of the accuracy means near to the true value. So means the true value, whatever the true value is there, no, for the true value, if the accurate value is if the value is very near, means that is accuracy. For example, if we want the value that is 100, just assume that we want the value 100. If it is just like we got the result like 99 also, it is the accuracy value. So the term accuracy refers to the agreement of the experimental result with the true value, and it is usually expressed in terms of error. In scientific experiments, it is known that true value is not known. It is simplified the value that has been accepted and is usually a mean calculated from the result of several determination for many laboratories employing different techniques. So accuracy means the value, whatever the experimental value we got, that should be very near to the true value. See, for example, let's think there are three persons. So three different persons, that is A, person B, and the person C. So they are shooting the arrows. Let's think this is the board. Three persons separate board A, B, and C. So they are shooting the arrow marks. The person, if you see in the board, there are different marks. That is, black color mark is, if the person shoots in the black color means he will get the 10 points. In the red color means he will get the 9. In the green color means he will get the 8 points. In the blue color means he will get the 7 points. So this is the 10, and red color is the 9, green color is the 8, and blue color is the 7. So person A, he has shooten the arrow marks in 2 arrows in the black color ring, means 10 points, and one in the red color means 9 point. So how many 3 are there? See here, 10 plus 10 plus 9. So how many points he got? 29. And if you see the person B, he has shooted one of the arrow mark in the black color, that is 10 points, and one is in the red color, that is 9 points, another is the blue color, that is 7 points. So how many got total? 10, 9, and 7. So 26 points he got. Next person C, he has shooten the 2 arrows in the red color. So that is the 9 plus 9. And here this is the 7. So 25 points. So person A, he got 29 points. Person B, he got 26. And person C, he got 25 points. So total amount of the points, what is the true value that we should get is 30. So 30 is the true value, but person A got the 29. So that 29 value is more near to the 30 value. So A has the nearest value and B has the somewhat just near to the true value. So it has the moderate accurate value, and C has the less accurate value. See here, if the person, I will explain it again. Let's think three persons are there. Person A, B, and C. So person A is shooting the arrow marks at different places. See here, if we shooted here 10 points, here 9, 8, and 7. So he has shooted 2 points in the 10 and 1 in the 9. So 10 plus 10 plus 9 means 29. And here person B has shooted the arrow marks in 10, 9, 7. So 26 points he got. Next, C has shooted in the 9, and 7. So he got 25 points. So the true value, what is the true value we should get means 30 points. So the person A has got the 29 points. So he has more near to the true value. So it is a accurate, more accurate value. And this is the moderate. So somehow if we compare the person A, the person B has somewhat difference, means not more nearer to the true value. So it is a moderate accurate, and person C is the less accurate. If we talk the second example, take the two persons, that it may be the X and the Y. They are performing the experiment in order to identify the percentage of the tablet, that is paracetamol. So standard value of the paracetamol is 100%. So we should get the result of the percentage is 100. And absorption, if we see that we have got for the X person is 99.80, 99.90, 100, and 99.30. See here 99.80, 99.90, 100, and 99.30. If we took the Y, 98.75, 98.75, 98.80, and 98.80. So these are the values these two persons have got. So who has done more accurate value we have to find. So if you see the solution here, so first if you take the X percent, so whatever the values he got, we have to do the average. 1, 2, 3, 4 values he got. So we have to do this 4 average values. That is 99.80 plus 99.90 plus 100 plus 99.30 by 4. How much we got? 399 by 4. So 99.95. So what is the true value? That is 100. So 100 minus 99.75. So what is the value? We got 0.25 percentage for the X. And for the Y percent, that is 99.75 plus 98.75 and plus 98.80 and 98.80. We have to do the addition of the 4 value and divided by 4. So we got the 98.775. So if we do the error, the 100 minus 98.775. So this is the true value minus this is the value that what we got after doing of the experiment. So that is 1.225 percentage. So the for which person have the less percentage of the error, that is X. See here for the X person has got a 0.25. For the Y person 1.25. So which person have the less error, that is X. So X has the less than Y. So he has done more accurate analysis. See here, I will explain it again. Let's assume that 2% X and the Y are doing the experiment upon the paracetamol in order to find the percentage. So what is the percentage? That is 100 percentage is the true value. So the 100 percentage true value, that what we should get after doing of the experiment. So the experts that these two persons have got the different values, that is 99.80, 99.90, 100, 99.30, 98.75, 98.75, 98.80 and 98.80. So if we discuss about the X percent, if we do these 4 values average means we got 99.75. If we observe the how much amount of the error he got by doing the experiment means we have to the true value minus whatever the experiment, whatever the value he got after the doing the experiment, that is 99.75. So he got the error is 0.25 percentage. Next, if we took the Y person values means if we do his values average, he got 98.775. So error is 100 minus 98.775 means 1.225. So if we compare the X and the Y person, the X has the less error when we compare with the Y person. So the X has done more accurate analysis. So next, precision. So repeatability of the value. So if the person has done the more experiments, if he done for the 3 or 4 times, so all the times the person should get same values. For example, if the person has did the experiment for the 3 values, first time he got the 10. Just think, first time he got the 10 points. So remaining second and the third time also he should get the same points. So that is the precision, means how many times he is performing the experiments. All the times he should get the same value. So precision is maybe defined as the degree of agreement between various results for same quantity. So it is refers to the reproducibility result. So good precisions are not necessary. Any analytical chemist always attempts for reproducible result to assure the highest possible accuracy. So the person, whenever he did the many as the experiment for many trials, all the time he should get the same value. That is a precision. So for example, there are 3 persons, A, B and the C. So these 3 persons are shooting the arrows on their boards. So person, this is the arrow board. This black color means 10 points, red is the 9, Green color is the 8 points and 7 is blue color is the 7 points. So the true value is the 30 points, the total true value. So if a person has shooted the arrow marks in the all in the black color, so that is 10 plus 10 plus 10. So he got the 30. If you see the B person has shooted here 9 plus 8 plus 7, he got 24 points. And here person C has shooted all the arrow marks here. 8 plus 8 plus 8, 24. So the person A got the 30 points, B got the 24, C got the 24 points. So what is the true value? What should we get? The true value is 30. So person A has more accurate. See here 30 points, 30 out of 30 points he got. So it is more accurate and also the values are repeated. So I said no, the precision is nothing but how many times of the experiments we have done, that all the times we should get the same value. See here, 3 times he had shooten the arrow marks. At 3 times he got the same points, that is 10, 10, 10. So repeatable. B means the points he got, whatever the points he got 24, but it is not more near to the 30 points. So it is less accurate, but these values are not repeated. See, the values are different 7, 8, and 9. And see, the 24 points is also not nearer to the 30, but the values are repeated 8 plus 8 plus 8. So, see here, 3 times have shooten in the 8 points. The values are repeated. If you see another example, like if you see the two persons, they are doing the experiment and estimated value is the 100, but and their observation values are person A, he got 97, 96, 99 and 96. And person B, 92, 91, 93 and 92. So if who has done more precise value. So if we see the solution, the standard deviation formula for the total population means if we took a class, in class there will be the total number of there will be the more member of the students. So in order to calculate the total number of the students present in the class, so for that person we have to calculate by using this formula for the total population, that is sigma equal to under root E and xi minus mu whole square by n. So this is the formula, that is sigma is equal to under root E xi minus u under whole square by n. So standard deviation for total samples. So for example, this formula is for total. If you take the class, in the class there will be the more some members of the students. So in order to calculate the total number of the students in the class, further we will calculate this formula. For example, if we want to calculate only the girls or only the boys, so only for some amount means for the girls and the boys, or maybe the girls or boys, so for that we have to calculate this formula, that is S is equal to square root E xi minus x bar whole square by n minus 1. See here S is equal to E xi minus x bar whole square by n minus 1. So if you see here for the problem, we are only calculating for the person A and the B. So not for the total population, just for the sum of the samples we are collecting. We are calculating for A and B for only some values, not total values. So in case of for only the sample, what is the formula we should take? This, that is S equal to E xi minus x bar whole square by n minus 1. So this is the formula we have to select for this sample, only some sample, not for the total sample. So if we took the x% mean value, so means whatever the values he got, that is 97, 96, 99 and 96. So this values has to be done the mean. Mean means nothing but the 4 values should be average. The mean value means average. So this total 4 values we have to do the average, and person A got the 97 and person B got the 92. So if you see the here A is equal to, for the person A, x and x dash x bar and x dash x bar whole square. See here in the formula it is there, no, that xi minus x bar whole square. For here the values we have to replace in place of the x. What are the different values the person A and B has got after doing of the experiments? See here, x is the 97, 96, 99 and 96. So these are the 4 values the A person got. So x dash x bar. So 97 minus 97 he got 0. And here 96 minus 97 means the 97 x bar value is the 97. So these are the values we got, that is 0, minus 1, 2 and minus 1. So if we do the squares for this value, so we got the 0, 1, 4 and 1. So if we calculate this total value, the person A got 6 points and person B got 2 points. So if we replace these values, 6, 2 values in this formula, that is S equal to E and square root E xi minus x bar whole square by n minus 1. So what is this value we got, xi minus x bar for the person A is 6. So we have to place 6 here. N means how many values are there here? See, 1, 2, 3, 4. So 4 values are there here. 4 minus 1 means 3. So under square root 6 by 3 means 3. So square root of the 3 is 1.414. For person B, what is the value he got? 2. So 2 by 4 minus 1. So 2 by 3. So 0.667, square root value is 0.816. So person A got 1.414 and person B got 0.186. So which value has the less, means which person have the less value, A or B? B. So B has the 0.816. So 0.816 is less than person A value, that is 1.414. So he has the more precision value when we compare with person A. Next, what is the difference between accuracy and the precision? So accuracy indicates how close the measurement is to correct or the accepted value. So I have explained, by using the example, the three persons have been shooting the arrow marks in different places and how much they got the accurate value. For example, if you want to get the 100 value, 100 is the true value. So if you got the 99 marks, means the 99 is number is also very near to the 100. So that is the accuracy. So precision means indicates the closeness of two more measurements to each other. So if you perform the different experiments, if you perform the 3 experiments 3 times, so in 3 times the person should get same value. For example, he got the value 10 in first time, and also in second and the third time also he should get the same 3 values. And second point is the measurement should be very close to the standard measurement, and the measurement will be similar every time your measurement. So when if we do any time, if you repeat this experiment any time, if you repeat this experiment all the time, the person should get the similar values, that is precision. So accuracy does not depend upon the precision, means if the person has been did the values, so the person whatever the values has got for the person, it should be very near to the very near to the true value. It may be the precision means it is not does not depend upon whether the values are repeated or not for the accuracy. And also precision is not dependent on the accuracy. Means if the person has been doing the experiment repeating times, means the value should be repeatable, but it is not necessary whether it is very near to the true value or the not. I will explain it again. Accuracy means whatever the value we should get, that value is should be very near to the true value. But the precision, how many times we are performing the experiment, that many times the value should be same. And also the measurement will be close to the standard value, but the measurement will be similar every time. And accuracy does not depend upon precision. Precision does not depend upon this. Let's discuss the sources of errors, means how we will get the errors. So the errors in the result in an analysis can be resulted from various sources. So from by using the various sources, we will get the errors. How many types? 5 types. First one is human source. Second one is instrumental apparatus and glasswares. Third one is experimental condition. Fourth one is constituents used in the analysis, means whatever the material we have used in the experiments, and procedure and how we are performing the experiment. First one is human source. So what is a human source? We. So how means the qualification and the experience. So if the person is the experienced person that he know how to perform the experiment, so then he will do the experiment without any error. So if the person is fresher, that he don't know how to able to perform the experiment, at that time there may be the some of the minor errors will be found in the result. So the qualification and the experience of the analyst performing the analysis has major impact in the result. So if the experiment is performed by the person, so if the new person is there, means the person who does not have the means experience and is a new person to perform that experiment. So if he done the experiment and he will get the analysis. So after completion of the analysis, he will get the result. So this result is compared with the same experiment was done. The person those who having the more experience, means the person those who have the more experience means he won't do the mistake. So there won't be any errors in the result. So that with the result, the new person without experienced person those have performed the experiment and he will got the result. So this result and will be compared with the experiment who has done the more experience. So by that way we can able to see whatever the errors are there, that is the human source. Next, instrumental apparatus and the glassware. So we will perform the experiment by using different instruments, apparatus and the glassware. So if their quality is not good, if the quality is not good means there will be the more errors in the experimental values. Next, experimental conditions means some of the experiments should do in particular temperature, in particular conditions. So some of the experiments will be more suitable if we maintain some temperature or some some areas. So if the person does not maintain a temperature or he does not did the experiment in the favorable condition, at that time the experiment will not able to produce the required result. And also the constitutions means whatever the materials we have used in the experiment. So the using of the different materials is also important. So if we does not use whatever the materials required for the experiment, instead of the required materials, if we use another materials also, the experimental values will get errors. And also procedure. So there will be the standard procedure in order to complete the experiment. So if the procedure went wrong also, in that case, the experimental errors will be occurred. First one is the human source. So if the experiment has been done with the experienced person means there will be the less errors. So if the new fresher person has done the experiment and he got the values, the value should be compared with the experienced person. Next, instrumental apparatus and the glasswares means if these are not good in quality, the instruments or the apparatus or the glasswares, whatever we are using during the experiment, if they are not good in quality, means we also get the errors. And also the experimental condition means if it does not perform the experiments in the suitable conditions, means if it does not maintain the suitable conditions for the experiment, means also get the errors in the value. And also constraints used in the analysis means whatever the materials we have used in the analysis, means in the other than that, whatever the required materials, if you should not, we did not use it, and instead of that other materials has been used, means we won't get the result. And procedure means there will be a particular procedure in order to perform the experiment. So instead of that procedure, any of the deviation has been occurred, so the result will get errors.